friends, today I can factor trinomials using the guess and check method. Alright, the next section deals with examples where the a value is not 1. This is a little bit trickier. We're going to start the same where we look at the second sign in front of C to determine if there's the same sign or different signs. We're then going to find factors of a and c and do some guess and check work to write a factored expression. So you can see how that's a little bit more vague than the last set of directions. We're still going to multiply outers and inners and add them together to see if we got the middle term of the original expression, and answer the question, does everything multiply out to the original trinomial? Okay, you always want to check your answer and make sure that it works. So look at the first example here. I see -10. So if I'm deciding same sign or different sign, because C value is negative, I'm going to say different. So it's either going to be plus minus or minus plus. If I look back, I see a minus sign in the middle. Now this is where it's a little bit more vague. When the a value is not 1, I don't take the time to look back, okay? Because you're going to have to do some more guess and check work than what you're normally used to. So let's go ahead and you'll see what I mean in a minute. I'll set up my sets of parentheses, and we'll start with first times first. First times first has to give me 2x squared this time. So I'm going to put that 2x times 1x gives me 2x squared. Last times last has to multiply to give me -10 still. So what are some factors of 10? 1 and 10, 2 and 5. Now normally I would write multiply and add here, but when the leading coefficient is not 1, you cannot do that rule. You have to think about this a little bit differently. Remember, whatever I put in this spot is going to be multiplied by 2, and whatever I put in this spot is going to be multiplied by the 1x. And you want your outers and inners to sum to -1. So this is where you're going to have to do some guess and check work. Like, would it make sense to put the 10 there? Well, then I'd have 2x times 10, and that would be 20x. That's going to get you pretty far away from the -1. Okay, let me show you how I can quickly narrow down the amount of options that I have. First question, did I have a GCF in my original standard form? Is there a GCF here? No, there is no GCF in the original form, which is why we went straight to trinomial factoring. So should there be a GCF in either one of these sets of parentheses? No. So, for example, let's say I use 1 and 10 and I put 10 here. Is there a GCF now in this expression? 2x plus or minus 10. Yeah, see how there would be a GCF of 2? Both of these terms would be divisible by 2. That's never going to happen. If there's no GCF in the original expression, there should be no GCF in one of the parentheses. Okay, so my only option there would be 1 and 10, to put it like that. 10 cannot be in the same set of parentheses as the 2, or else you'd have a GCF. Here my outers would be 20x, and my inners would be 1x. There's going to be no way to take 1 and 20 and get to -1. So I know that 1 and 10, those factors, are out. So now I'm working with 2 and 5. Could I put the 2 here and the 5 there? No. Again, if you look at this parenthesis, see how both terms would be divisible by 2? And you'd have a GCF. If there's no GCF at the beginning, there should be no GCF within the set of parentheses. So I'm not even going to look at that as an option. So really, the only option I have is put the 5 there and the 2 there. Okay, now my outers would multiply to give me 4x, and my inners would multiply to give me 5x. How am I going to make this sum to -1x? What has to be negative, the 5x or the 4x? The 5x has to be negative in order to get the -1x. So this would have to be -5 times x, gives me -5x, and then 2x, 2 would give me a +4x. right? We definitely wanted to have different signs. So we have the negative in front of the 5 and the positive in front of the 2, and that should work. Okay, check your answer, multiply it out, make sure it makes sense. 2x times x is 2x squared. Last times last, the negative 5 times the 2 would give me the negative 10. And when we checked our outers and inners, we already confirmed that we get negative x. Okay, take a look at the next one. We see a positive c value. So that means that we're going to have the same sign, either both plus or both minus. I'm going to set up my parentheses. First times first has to give me 3x squared. So I'm going to use 3x times x. Last times last has to multiply to give me 8. So write out your factors of 8. You would have 1 and 8, 2 and 4, and that's really it. Okay. All right. Again, normally I would say, what multiplies to give you this and adds to give you that, except for it doesn't work like that when a is something other than 1. So I'm not even going to bother that step. We just have to start guessing and checking. Remember, whatever you put in this outer spot is going to be multiplied by 3. So be careful here. Let's just start plugging in numbers. Don't be afraid of it. If I do 1 and 8, my outers would be 24x and my inners would be 1x. Is that going to work? No? Okay, let's flip-flop those. I'm going to put the 8 in the first parenthesis and the 1 in the second. Now let's see what we have. We would have 3x on the outer part and 8x on the inner part. 8, 9, 10, 11. That could get us to 11x. So that does not work. I'm going to get rid of that option altogether. Let's try the next one. We have 2 and 4. My outers would give me 12x and my inners would give me 2x, which, yay! Yay, we got one. That sums to 14. That's what I want. So remember, it's got to be the same sign. Because all of these signs are positive, I'm guessing that all of these signs would be positive, which would give us plus 2x and plus 12x, which would give us the plus 14x. Okay, so that looks good to me. You can always check your work. First times first would be 3x squared, and 2 times 4 would be 8. Let's look at number 3. Again, we see plus 3, so I know to use the same sign. This is another one where everything's positive, so I'm guessing that I'm going to use plus plus. Set up my parentheses. First times first has to be 12x squared. So that's kind of tricky because the last ones, like 3x squared and 2x squared, we only had really one option. But with 12x squared, we have a couple different options. So I'm going to write those down. We could either do 12x times x would be 12x squared. We could do 6x times 2x would be 12x squared. We could even do 4x times 3x would be 12x squared, right? There's a couple different options, so I'll just list all of those for now. Then we know last times last has to be 3. So really the only thing that gives me 3 would be 1 and 3. Let me ask you a question. Could I put a 3 in this set of parentheses? The answer is no. Why not? It's because this original function did not have a GCF. So if the original function does not have a GCF, then should one of the factors have a GCF? No. See how right now both of these terms would be divisible by 3? We don't want that. So I just don't even look at that as an option. So it would have to be like that, if anything. Could I put a 3 in here? No, same reasoning. See how we'd have a GCF? So that's not even an option. So the 1 would go there and the 3 would have to go there. Could I put a 3 in here? No, same reasoning. If there's no GCF in the beginning, there's not going to be a GCF in the factored form. So in that case, the 3 would have to go there and the 1 would go there. Okay, so let's just take a look at the outers and inners and see what gives us a positive 20x. Here my outers would be, let's see, 12 times 3 would be 36, 36x, and my inners would be 1x. That's not going to get me to 20. That's out. Okay, let's move this last guy down just so we have a little bit more room. Here we would get that the outers would be 18x and the inners would be 2x. So yay, that actually works. That gives me 20x in the middle. Okay, remember we were supposed to have the same sign all along because we saw pluses everywhere in that original standard form. So I'm going to say that this would have to be 6x plus 1 and 2x plus 3. All right, good deal. Remember, you could also write this as 2x plus 3 and 6x plus 1 if you'd prefer that. Yeah, guess and check can be a little bit daunting, but don't be afraid to make mistakes and change up your answer. Okay, now in number 4, we do have a GCF. This is the first time I see a GCF. What are all 3 terms divisible by? What's the largest number they're divisible by? I think it's 4. So if I factor out a 4, I would get 2x squared minus 7x minus 4. Okay, and you can see how I still have a trinomial left here on the inside. So I'm going to use trinomial factoring on that inner function. So look at your C value. We have minus 4 there. So I know that we are going to be using different signs. So either plus minus or minus plus. And we'll set up the parentheses for that. We know first times first has to give me 2x squared. So I'm going to use 2x and x. And last times last has to multiply to give me 4. So that would be 1 and 4 or 2 and 2. Well, I'm not going to use 2 and 2 because see how this trinomial no longer has a GCF in it? We've already factored the GCF out. Because of that, I shouldn't see a GCF in one of these factors. So I'm going to throw 2 and 2 out. So same reason why I wouldn't put the 4 in the first set of parentheses. We'd have a GCF. So you can see that helps us eliminate a lot of the options. Okay, that looks good. And just make sure first times first would be 2x squared. That looks good. Outer times outer right now is 8x. Inner times inner is 1x. But remember, we need to create different signs so that my outers and inners give me negative 7. So if I want negative 7, what would have to be negative, the 1x or the 8x? 8 would have to be negative in order to get a negative 7x. So this should say 2x times negative 4 for my outers to give me negative 8x, and then positive 1 times x to give me an inner of 1x. Okay, and I think that should work. Just like that. What am I missing? I'm missing this 4. Don't forget to put your GCF in your answer. Okay, that follows it down. Okay. Okay, and this last one here, we see a positive 16y squared. It's okay that that last term is not a constant because we actually have 2 variables in this expression, both x and y. So I think that this is still going to work where we're going to use the same sign, either plus plus or minus minus. Because I see a negative 10, I'm guessing we're going to use the minus minus. Okay, set up my parentheses. First times first has to give me x squared. So I know that I'm going to fill that in with x and x. And last times last has to give me 16y squared. Ooh, that's kind of tricky. I know that we're going to have y times y there in order to get the y squared, but I'm not sure what to use as a coefficient. Let's think about what are some factors of 16. We have 1 and 16, 2 and 8, 4 and 4. Is there any way that we can get negative 10xy. Well, let's just start plugging it in and see what happens. Let's say that I use 4 and 4. My outers here would be 4xy, and my inners here would be 4xy. So that would only get me to 8xy or negative 8xy if I made these all negatives. Okay, that obviously didn't work. Let's try 2 and 8. So I'm going to make this negative 2y and make this negative 8y. Let's see if that works. My outers would be negative 8xy, and my inners would be negative 2xy, and those would sum, woohoo, to negative 10xy. Okay, so that one worked, right? That's what we were looking for, was negative 10xy. So I'm going to say that my answer is x minus 2y times x minus 8y. You could also write this as x minus 8y times x minus 2y. Either one of those would be appropriate answers.